In our last video we showed you uncut diamonds, but today we're going to take you behind the scenes and show you how a mega diamond like this one is cut and polished into something like this. But first, to the room where diamond deals get done.
This room is where it happens, where people come and look at the diamonds and decide, do I want to buy it or not? Or perhaps, can I afford to buy it? So over here, we have a selection of diamonds which are about to be auctioned. This small collection is worth about $10 million. My favorite one is the one over here because it sparkles so much. Can you take this one and put it on its face? And you can see it is shaped in a pyramid or a cone, and it has 57 different faces, which gives it this really beautiful sparkling colour. This is called a round cut, presumably because it's circular. You can also have diamonds cut in the shape of a heart. Last time we showed you diamonds, I got really excited when they fluoresced. For me, that was the best part of all. I thought they were much more valuable. I now realise that I was completely wrong. Fluorescence lowers the price. Here, when people are buying, they check the fluorescence again. So there is a fluorescent lamp, and perhaps if we try that one first. So you can see this one is fluorescing relatively strongly, and this will probably affect the price. So let's try another one. And you can see that one isn't fluorescing at all. So this one's my favorite. Can we check this one?
Good luck. Nice.
No.
Nice.
So it's okay. I chose a good one for once.
Are you still going to buy that one then?
No, I think I'll leave that for you, Brady. This cut, which is called a princess cut, is technically the most difficult to do because of the very square shape. And so in terms of the actual processing, this is the most difficult one in the whole box. So now we've got some really special stones. Those three stones together are probably worth $30 million. The most exciting one is this pink one in the middle. You may have read about it in the newspapers. It's just been cut. It's going to be sent for auction. Nobody knows the true price that they'll get. Tens of millions of dollars. And we on periodic videos are giving you a preview. Can you take it down? So this diamond is 14.85 carats. That's not quite 3 grams. But when it came out of the ground, it was more than 27 carats. So you can see that nearly half the mass of the diamond was lost when it was cut. And this lost diamond disappears as dust. This, it's got a special colour called fancy deep purple pink. And it's the largest diamond of this colour that has ever been found and polished. I think I prefer it to the pink one. And it's cheaper. I could get 2 or 3 of these for the same price. This yellow one is also very interesting. The yellow one is yellow because of nitrogen in the lattice. Every so often, one of the carbon atoms in the lattice has been replaced by nitrogen, and it is these nitrogen centers that give it the yellow color. The pink stone is different. The color doesn't come from an impurity, but the fact that every so often there is a mistake in the lattice, and these dislocations in the lattice give rise to the color. We're now in the room where they polish the diamonds. The key effect is obtained by getting the precise angles between the different facets that you polish. So over here we have a machine which is a spinning disc going at 2,600 RPM with diamond dust on the disc. So polish the surface. The operator has a plan for his particular diamond which tells him what he should do, which angles. Much of the time is spent adjusting the diamond before you actually polish, because if you get it wrong and make a mistake, you've had it. Each of the tools has a little spirit level on the top so that you can make sure that it's absolutely flat, and so the angle you'll get is correct. This here is the diamond that Ebelyakh was polishing. Here is his plan, and then here on the computer screen are the angles between the faces that is measured to see how it compares with the plan and what it should be doing. Of course, when you grind it, you get a lot of dust, and so there are extractors, like a fume cupboard, that are sucking air all the time to remove all this very fine carbon dust, which is generated when you grind the diamond. It's amazing to me that so much of the diamond has to be wasted, so it's just blown out, presumably onto the roof of this building. This is not at all what I expected, but it's really good because it shows that you need huge technical experience to turn these diamonds, these rough diamonds, into something that people want to buy and wear. I suppose I expected it to be much more mechanized, but since every diamond is different, you have to do it by hand because you can't get automated machines that will treat each one completely differently. Here we're just looking at one of the discs, and you can see they can change the discs. It's a bit like your home electric drill or electric polisher, but of course this is much more sophisticated.
What does this feel like? Is it rough or smooth or?
Можно трогать. So I'm about to touch the disc to see what it feels like. I expect it to feel a bit rough, like a nail file. Feels completely smooth. Wouldn't know there was any diamond dust there at all. Bit of a disappointment. Well, I think it's smooth because the diamond particles are so small that our fingers are too insensitive to feel them. Because if we could feel it, it would probably make scratches on the diamond. There's the man who polished the pink diamond. Took 2 months. A 1 carat diamond, which is 0.2 of a gram, 200 milligrams, takes 4 or 5 days to do. A big one like the rose diamond took 2 months, and the biggest diamonds they do take half a year. It's quite warm in here. It's very noisy compared to, say, an ordinary lab, but not terribly noisy. And there's a slight smell, perhaps an oily smell. This is the machine for measuring the angles. The diamond is spun round. There is a light beam coming down here, some sort of light source down there with a lens system in here. And the focus beam is then reflected. And because they know the speed, they can measure the angle, and it all comes out on the computer. This is Anatoly. His computer is the design for the rose diamond, the really valuable rose diamond, showing how they decided how to cut it. The light part is the outline of the rough diamond, and the blue is the finished rose stone which is going to be sold, which we've seen. The yellow part is the reference plane where they cut the diamond so they have somewhere to start with, and then all the angles and everything else are referred to that orange one. Green places are defects, and so what they've had to do is very, very carefully design the cut so that it cuts out the defects, but without wasting any of the good part of the diamond. But you can see on here how much of it has to be lost to produce something that looks really good in a piece of jewelry. Here you can see on the screen the rough diamond with all its defects. It's done by a special company that does the measurements, and then it sends them here. They designed the shape not so much to get the maximum weight, but to make the rose color, the pink color, as strong as possible. This is showing where they cut the first face. They use a laser to mark the edge of the piece that they're going to cut off. The precise instructions are on a piece of paper, but then they're physical markers so that the person who is grinding it knows exactly where to go to. This is the department where they cut the diamonds with the laser. You need to waste as little material as possible, so the laser beam needs to be as tightly focused as you can. At the same time, you don't want to heat the diamond too much because it's carbon. In principle, it could catch fire. So you use a stream of water which focuses the laser beam. You get a spot about half the size that you would do in air, and at the same time, it can cool the diamond, but of course it makes it harder for Brady to film. One of the skilled polishers can remove a carat of material a day. That's 200 milligrams. This machine can do it in 20 minutes. They didn't use this for the rose diamond because if something had gone wrong, it would have spoilt everything. When you're polishing by hand, you can see exactly how things are going. Marina is holding a crystal which has been cut, and you can see here it is, the two parts together, and then you can see how they have been cut into two pieces. The advantage is that with this method, you can still get something out of the little piece. You can make a little diamond, and this one will be processed to make a much larger one. What's really surprising to me, at least at first, was that the cut surface is black. And the reason is that the laser converts the diamond just close to where it is cutting from the traditional diamond structure into graphite. You need a very high power laser, far too big to go in the box. So the laser is out here, this long rectangular box, and the light beam then goes down an optic fiber, glass fiber, into the box where you cut it. But what is really important is the purity of the water. So these big boxes here are continuous purification of the water and cooling of the water, because the heating of the laser generates a lot of heat. So you have water purification, laser, and the actual cutting is here in the box.